This interview is recorded as part of Big Data Public-Private Forum project activity, or simply BIG, to create European Big Data Technologies Roadmap. Hi Matt, hi Kelly. Could you please briefly introduce yourself and give a little of your background related to big data?
Hi, I'm Kelly Stirman. I'm the Director of Product Marketing at Tengen, the MongoDB company. And prior to my work at Tengen, I worked for a company in the Hadoop space, which is certainly part of the big data story, a company focused on the SQL on Hadoop market. And then prior to that, I was at a company called MarkLogic for over 8 years. And that's a company focused on large-scale document database systems where the data model is XML.
And my name is Matt Asay, and I'm Vice President of Business Development and Corporate Strategy at Tengen. And in terms of big data, I actually would argue that big data has been around for a long time. It just now finally has a name and has technologies that make it very cheap to use. But most pertinently, in addition to Tengen, I was Vice President of Business Development at a company called Notable, which did real-time analytics based on the open source Storm project out of Twitter. And that was probably the extent of the quote-unquote big data focused things, but I've had 10 plus years in working for various open source companies and in the open source community.
So let's start actually from the big data buzz. It's well known that the world generates more and more data each year, but it was always the case. If I would ask database administrator 20 years ago and today, they both would worry about the storage space left and about computer performances. So what is different today from situation 10, 20, 40 years ago that caused big data buzz?
I think that's a good question. I mean, part of your point is big, the sense of big is relative. And for, there's always been big, as long as we've had computers, right? It's just whatever is larger than you're probably comfortable with. I think what is different today and why there is so much there's so much effort and consensus around the concept of big data is the confluence of two things. One is that the resources that we use to store and process data have become incredibly cheap. It used to be, that a database that stored hundreds of megabytes was something that might cost as much as a house. And now people carry, hundreds of gigabytes of capacity in their cell phones. And the cost of storing terabytes of data has just become so incredibly inexpensive that it's really, it's now possible to store things in a way that we maybe couldn't in the past. The other thing I think that has changed and why big data is now there's so much interest about it is that there's historically been many systems around to process different parts of the operations for businesses. But what's happened really in the past 10 years is that the quantity of time that an average individual spends online has grown dramatically, right? Because as individuals, we have cell phones, we have computers, we have all sorts of devices, and we are constantly online and interacting with systems and creating data, right? So the creation of data has exploded, and people used to just sort of throw that away, but now it's so cost effective to store the data that people are holding on to it, and that's, I think those are two really important things that are driving the interest around big data.
Okay. And looking 5 or 10 years ahead, how do you think big data technologies landscape will look like? Specifically, it would be interesting to understand, okay, so we have a cheap storage now, and we can store a lot of data, but in 10 years from now, we'll have to store, I don't know, 20 times more data. Will we be able to do it?
Well, so let me, this is Matt, let me interject really quickly and then I'll let Kelly finish it. Every and Kelly kind of intimated at this, every year what we call big this year will be small next year. And orders of magnitude, we just keep growing orders of magnitude bigger in terms of the data that we ingest. I think what we're already seeing is a shift away from the concern about big data as in big, like volume of data. That will become less and less important, and it already is. What's increasingly important is big data as speed, the velocity that you're able to ingest that data and make use of it in real time, and the variety of data that we can ingest. So today, and this is one of the reasons that relational databases have proved such a poor fit for big data, is today we have maybe a Twitter feed and your Facebook, and you have all this other social data. You maybe have machine-to-machine data. Tomorrow, who knows what kind of data we'll be consuming, and this ability to take semi-structured or unstructured data is a hallmark of NoSQL databases, of Hadoop. And I think what we'll see then is this ability to continue to master all of these disparate data sources and put them to use in real time. And that will be the big shift. And we'll stop talking about how much data there is, because that's already becoming just kind of a given, that there's lots of data. So it's what you do with it in real time that starts to matter.
Yeah, I'll try and just say that slightly differently. Right now, the focus is just on storing it, by and large. Where we're headed, where things are moving is, how can I actually put the data to work? How can I make it serve the interests of the citizens of my country, or generate more money for my business, or help discover cures to diseases, or however we want to put it to work. The future is about not collecting the data and marveling at its size. It's about putting that data to work to solve real problems.
Okay, thank you. And you mentioned the NoSQL databases as part of this vision. So what are the major trends in NoSQL databases, and what we will see in next 5, maybe 10 years in this area?
Well, I think what you've seen recently is an amazing proliferation of databases, right? I mean, just the concept of databases has been around about as long as computers. The relational database has been around, effectively around 40 years. But there's really just, been a handful of relational databases that are legitimately used in the market. In just the past 5 or 6 years, NoSQL has come to exist, or NoSQL, and there are already well over 100 products. I think what we will see, one of the trends we will see, is just as in any sort of new market where you have lots of entrants in the beginning, eventually there's really just a few emerging winners in that space, where there will be a handful of NoSQL products that people actually use. And you can already start to see that happening, where legitimately there are just a couple of different products that people are really interested in, and where you see lots of momentum. And you can measure that momentum in the areas of the size of the community around the products and the size of the companies that are building commercial offerings around the products.
Okay, what do you think is the most important current issue for NoSQL technologies? What is the most important problem today?
Yeah, so I think right now there's an enormous market that can be addressed by NoSQL technologies. The challenge is they actually represent new ways of doing things, right? The people that are used to working with relational databases benefit from decades of people using these technologies and an ecosystem of other tools and best practices and skills that have developed around the relational database. With NoSQL, you have really it's new, so you don't find that everyone knows it. So I would say the number one challenge right now is just the availability of skills and individuals who are capable of using the technology effectively. The second thing I think is the maturity of the products, right? You cannot write a database overnight. These things take time. And that's partially why open source is so important, because what you really want is lots of people contributing to the product, lots of people exercising the technology and finding the weaknesses and addressing those weaknesses quickly and efficiently, and then immediately putting the technology back out into the wild and putting it through its paces and continuing to develop and mature the technology very quickly. Whereas with proprietary systems, you might have a very small number of users. One of the real appeals of open source is just the incredible number of people who use the technology and can ensure that it is of high quality. So I think those are two really important things to think about: are the skills and the maturity of the technology, and the size of the community around the technology. So when you're looking at NoSQL technologies, those are two incredibly important criteria. And just as one data point, for example, MongoDB has free training available, and we didn't know how appealing this would be to the market, but we now have over 100,000 people who have registered for our free online training. And that training has only been available for about 9 months. So we will continue to invest in making it easy for people to learn the technology, because clearly there's interest and demand.
Okay. Another question. The database landscape is actually very diverse today. I mean, vendors like Oracle, Microsoft, HP offering relational databases with massively parallel processing. And in addition, there is a new SQL wave of databases. So can you give rules of thumb when to use NoSQL databases? Then actually someone have to use new SQL? And specifically when to use document-oriented database like MongoDB?
Yeah, that's a great question, because the appeal is the new SQL products have a SQL interface, they have a relational model, and these are familiar concepts to the vast majority of IT shops. When you look at those products in the market, they are very new, they are very immature, and so they really, in that sense, have some of the same challenges that the NoSQL products have as far as maturity and the size of users who are capable of using the technology effectively. The more important thing, though, is most, if not all, of those products make certain compromises to enable the relational model and relational technology to scale out across many computers. And that's fundamentally what is driving new SQL, is how do I take this nice thing that I know and love called a relational database and make it scale across many computers. And if you look at most of the offerings, they require you to give up some of the things that are really appealing about the relational model and relational technology in the first place. For example, in most of them you have to give up joins. For example, in most of them you have to give up transactions or complex transactions. And the list goes on. And what you end up with is sort of a crippled relational database that, while it can scale, it doesn't have all the things that are appealing about the relational database in the first place. So that's one thing. The second thing, when do you think about using new SQL versus NoSQL, is the real appeal of document databases, and this is true for MongoDB and some other document databases. It's not necessarily true for key value stores and some of the other products in the NoSQL space, is that the data model is extremely straightforward and appealing to the developer, because the way you store the data is almost exactly the same as the way you work with the data in your application. And so what you find is that developers can can develop their applications more quickly, they can adapt to change more quickly, and they can embrace complex data models much more effectively with the document data model than they can with a relational data model. And we think that this is appropriate for about 80% of the applications that people are writing today. There are certainly things, certain types of applications where the data model and capabilities of NoSQL products are not appropriate. But when we think that the vast majority of the time they are appropriate, and so that when people look at how am I going to build the next application that I need to build in my business, the real question they're going to ask themselves is, what helps me get there most quickly and most cost effectively? And in most cases, we think that is going to be NoSQL, specifically document database.
Okay, thank you, Kelly. It was very interesting. Well, as I mentioned earlier, we as a project mainly interested in the roadmap, so I have a few questions about the roadmap. MongoDB is very popular and very successful NoSQL database. Why do you think it happened? What factors have influenced this?
So,
go ahead, Matt.
well, I was going to say, I'm going to give you a break for just a second, in part because I was answering this question last night. So I'll start, and then Kelly is very good at finishing and going into more detail than I do. I think the number one thing that the early MongoDB developers did, and that they continue to do, is to really focus on the developer, making it an exceptionally easy experience out of the box so that you can get started, start coding, and then become productive really, really fast. An example that I like to use is the city of Chicago, and then to be able to scale, so that simplicity scales. An example that I like to use is the city of Chicago, where Brett Goldstein, who was then the chief data officer, he decided that he needed a predictive analytics platform, a big data platform for the city, so that they could track crime and predict where they might need more police, where they could predict where they might need more healthcare workers based on flu outbreaks or things like that. So Brett didn't start with any budget on this, though. And so what he did is he downloaded MongoDB on his laptop and started tinkering with it and built out the project on his laptop. And then from there, as he did a proof of concept, he just grew it out. And now it's running on many nodes within the city, and it's called the Windy Grid project. But that really is I think the central, somebody's coming to arrest one of our employees.
That's me. I live near a hospital. Apologies.
That's all right. I knew it wasn't someone in the EU because those weren't UK sirens. Now it's kind of odd not hearing the background noise on you, Kelly. But it was really that focus on developers and making it super easy out of the box, and then making it so that as you go, you can flexibly change the schema. And that's something that, frankly, that MongoDB does much better than any other NoSQL database, and certainly better than any relational database. I heard the founder of one of the other NoSQL projects, and he was quite dismissive of MongoDB for that reason. He said, some databases are really worried about ease of use. That's not what we care about. We care only about really high performance. The problem is, A, I don't really know that his performance is any better, but B, the problem if you focus only on performance at the expense of ease of use is that very few people will bother to take the time to learn your database so that they can actually experience that performance, because they spend all their time trying to get it set up and optimized, and they generally fail. So MongoDB has taken that out. And then there are some other things. I do think that the document model is, for the reasons that Kelly expressed earlier, is a better model. It offers a general purpose database, and for developers, it's fine to have, if you create a key value store or a column database or a graph database, the range of applications for which you can use that is actually pretty limited. And so what you end up doing is you'll use it in one project, and then you have very little reason to use it in another project. So maybe you might use it in Oh, I'm thinking of an example that we have recently. You might use it in for a genealogy application, if you're the LDS Church, as an example. But for your other applications within your mobile application that you want to build, it's not really an ideal solution, and so you end up using it just once. Whereas with MongoDB, sometimes it will be the absolute best thing. Other times it will be a really good solution that might not be the 100% best solution, but because it's the database that you already know as a developer, you're probably going to use it again and again and again across a wide range of applications. And that's how we see adoption going. Places like Disney, places like the Guardian newspaper, where they start with one project and then they grow it out to a wide variety of other projects, to the extent that the Guardian now has a policy, a MongoDB first policy, where the default is always MongoDB, and you have to basically prove why you would a compelling reason to use any other database, because it does have that broad flexibility to handle an array of use cases. Kelly, if anything?
No, I think that's good. I think making it easy to use turns out to be an incredibly powerful enabler. Again, if you go back to, the two things that are potentially threatening to the success of NoSQL, which are the availability of skills for people to use it, and second, the maturity of the underlying technology. By making it incredibly easy to use, you ensure more people use it, and the more the people use it, the better it is exercised and the more quickly it matures. We certainly are not, at MongoDB at least, focused on addressing one or two specific applications exclusively. We are focused on building a technology that is general purpose and addresses a very wide set of use cases, because it makes a larger market where more people are interested and where the product can mature more effectively. And I think what you see when you look at all the different measures, from the number of skills available on LinkedIn to the number of tweets, the number of blog posts, the number of job listings, virtually every measure available, MongoDB is not only the largest community within big data, but it's also the fastest growing. And that's even compared to Hadoop. So I think those are two. I think we made some of the right assumptions when we started the project, and how we've developed and matured the project with the community over the past several years.
Okay, thanks. Can you tell me what type of organizations are your main customers, and why did they choose it? Do you expect other types of organizations to start using MongoDB?
Yeah, so I think what we saw very very early on for MongoDB, and it's different. The stories are quite different when you look at some of the different NoSQL technologies, and when you look at Hadoop. For MongoDB, we saw early adoption first among startups, and that makes a lot of sense in retrospect, because it's the people that are looking to develop quickly, to prototype a concept, to test a hypothesis in the market, and quickly incorporate new features and embrace the competitive pressures and change that they face every day, right? And MongoDB is great for that, because it's incredibly easy to use. The data model is dynamic. You don't have to make a bunch of data decisions up front. You can just iterate on your data and on the functionality of your application extremely quickly, right? And so those were in the early years, but what we found is that those attributes of a startup are very desirable to mainstream companies, right? What business wouldn't want to adapt to change quickly, to implement their applications in a fraction of the time, to make their developers vastly more productive, to deploy data management systems at a fraction of the cost of relational databases, to run the entire system in the cloud in some cases, right? That's really important for startups where it might be a few guys or gals in a garage somewhere, and they don't have a bunch of servers. They just want to do everything in the cloud because they can pay for things as they use them, and they don't have to spend a bunch of money up front. Those are all things that a business would want to do. And so what we found, especially in the past 2 years, is that our customer base has quickly shifted from being dominated by startups to being a very healthy mix of startups and Fortune 500 companies and global Fortune 500 companies. So now we have large global banks, some of the world's largest telcos, some of the world's largest retailers, large industrial equipment manufacturers, governments across the world. Like, it's literally everybody is using MongoDB now because it's the most widely used big data technology out there, and the things that were appealing to startups have become extremely appealing to big companies as well.
Okay, thanks. And now then we understood the past. Question about the future. What major features and capabilities we might expect from MongoDB in the next 5 years?
Yeah, 5 years is a long time. And no promises here, but I could tell you about the kinds of things that we think about. So first of all, we want to maintain our focus on empowering the developer community, right? We understand that market has been key to our success, and we think that's the right focus to continue to maintain, is continuing to make MongoDB easy to use, powerful for developers, and really their first choice for a fundamental database for their applications. We've started to focus over the past few releases on addressing the operational side of MongoDB, where, Matt mentioned earlier, some companies started with, look, we really just care about the operations of the system. We don't really care so much about how easy it is to use. With MongoDB, we really were focused on ease of use initially, but some things around the operations, especially for systems that have hundreds of computers, they could be a little, they can be sort of resource intensive and not as easy as they could be. So what you see us doing, for example, this year, is building out that management layer around the core database kernel so that it's easy to monitor and manage and automate all of the things that you need to do around a MongoDB system. The third thing I think you'll see us continue to work on, that we've already started to work on, is making MongoDB play nicely and fit into the standard ecosystem in a large organization. So if you look at Fortune 500 companies and large governments, there's a long list of things that they expect in any sort of enterprise product. Things around security, monitoring, management of the infrastructure, integration with certain standard products like BI tools. And you'll see MongoDB continue to make it easier to have the technology fit into the standards of a typical enterprise. And that will come as a combination of enhancements to the core product, but also through partnerships with companies like IBM, ClickView, Cognos. There are many different companies that we need to integrate with and interoperate with, and you could see that in the sorts of partnerships that we have underway. And I'll let Matt talk more about that.
Oh, I think you did a good job. Maybe the only thing that I would say is that I think on the partnership side, I think we're going to see in NoSQL the same or similar things to what we saw in Linux, namely that I think the market will rally around a single vendor, not because the industry loves lock-in or anything like that. It has nothing to do with that. But there are actually a lot of benefits to standardizing on a dominant vendor or a technology. And in Linux, that happened to be Red Hat Enterprise Linux. And I think we're already seeing the same thing in the NoSQL world, and it's a lot of it just has to do with enterprises. So RedMonk came out a little while ago. RedMonk's an analyst firm with an office in the UK. RedMonk came out a little while ago and talked about how we're going to have a range of databases, since developers are now playing such a key role in determining which technology gets used in the enterprise. They will use a wide array of technologies, and they won't standardize. Well, it is true that developers have an increasingly important role to play. It's also true that that no enterprise wants to standardize on 25 different technologies. They want to coalesce their efforts around a few technologies. So I think one thing that we will see is this continued winnowing down of the main databases in NoSQL. And frankly, I think we'll continue to see MongoDB as that top database. I think we'll see Cassandra as a strong contender. And in terms of partners, what we've already seen is that these partners like Informatica, like ClickTech, and so on, they all have, similar to the Linux world, they are all certifying for one and possibly two platforms. So in the Linux world, it was Red Hat first, and then SUSE second, and then they didn't. And I worked at Canonical, the Ubuntu company, and it was actually very hard for us to get anyone to certify for Ubuntu. And I think we'll see the same thing in NoSQL, where these partners will certify first, I think, for MongoDB. That's been what's happening so far. Second, for something else, depending on where their focus is, probably Cassandra or maybe React or something. And then they just won't have the cycles, the engineering cycles, to be able to certify for others. And so I think we'll see within the enterprise, we'll see this solidifying of leadership among just a few NoSQL solutions. And fortunately, the good thing that we have now, so at one time I think this would have been a very negative thing for the industry. The thing that we have now that's very positive is that in every case, the databases of which we're speaking are open source. And so this ability to lock in is not completely eliminated, but heavily mitigated. And so I think we end up in a situation where people can comfortably standardize, like IBM has, where IBM came out and standardized on MongoDB for web and mobile application development. We can see other people doing this as well, knowing that at the end of the day, it's open source, and so it's a pretty safe bet to be able to standardize on open source technologies.
Okay, thanks. I actually have a number of questions about standardization and integration, but before we go to those questions, I have one more question about the future. As in our project, we are trying to understand interdependency between different technologies. So my question is, do you have any problems that require research or that require other technologies to appear on the market? Or are you self-sufficient?
Are you asking in the sense of, are we dependent on anything today, or are you asking in the sense of, are we dependent on something happening in the future?
In the future. I mean, for example, if you see a specific direction there you want to go, but you can't go there right now because there are some preconditions, like, I don't know, language standardizations or whatever, and you can't go in this direction right now.
Oh, I see. Yeah, I actually don't think there's anything. I mean, it's the future, right? So we could certainly be wrong, but right now, I think the one underlying assumption that we've made, that it is important that this remain true, the one underlying assumption that we've made is regarding the resources for these systems, that they will continue to commoditize in a reasonable relationship with data growth, right? So what we talked earlier about the explosive data growth, but we've also had this sort of explosive cost reduction for resources and the availability of resources through things like the cloud, right? So we one of the underlying assumptions for MongoDB is that the the way hardware is moving is that it's commodity resources where it's lots of small, inexpensive computers, not supercomputers, not mainframes, right? And so if it turned out for some strange reason that the market suddenly made a left turn and went back to really big monolithic mainframe type computers, we would probably need to make some changes to the product. But we believe that if we had to do that, we would make those changes more quickly than the hardware market would evolve, right? That a change like that would be dramatic and is very, very unlikely to happen. But I think that's the only underlying assumption we have right now, because we're based on things that are largely open standards where there's already tremendous momentum, and so I think you could see that the sorts of assumptions we've made thus far have really played out well.
Okay, thanks. Matt, previously you said that we should expect standardization on specific systems. Right now there are 5 popular data models today. I mean, relational, key value, column-rated, document-rated, graph data models. So do we really need all 5, or should we expect that only 1 or maybe 2 will survive in the long run?
So that's a good and a hard question. I can say both because I'm a little biased in the matter, but also I'm biased because I think it's true. I do think that the document model will be one of those things around which the industry standardizes, in large part, again, because it's not just a single purpose database model. It's a general purpose data model. And I mean, I think it's important not to underestimate this human desire to just get things done, even if the technology is not always a 100% perfect fit for every single application you could possibly want to do. You think about all the times in your life where you use a technology, not because it's necessarily always the best, like your mobile phone. You might carry it with you, even though you often get bad coverage, cellular coverage. But you carry it with you because it just happens to be the most convenient and most powerful overall for your needs. And I think that the document model, because it serves this broad array of use cases, and I think today we can handle, I think Kelly said, 80% of the world's applications. You could conceivably, and I think productively, use the document model. I think going forward, that percentage only increases, and going forward, the document model will be the ideal choice for most applications, rather than, and I think we'll kind of leave behind the relational model. Now, coming to the other things, I think it's still too soon to say what will leave behind. I think it's likely that there will always be different database technologies that don't serve a broad need but serve a particular need so well that they will be used in niche applications, important but niche applications. And my hunch is that that's where we'll see key value stores go. Generally speaking, I think the more broadly applicable the database technology, the more likely it is that it will become an industry standard. And again, we'll see these more niche technologies. And again, I would probably say, Kelly might disagree, but I would probably say key value and graph databases are those things that we'll probably always have around, but we will use them sparingly and for very particular use cases.
I will disagree with you partially. Key value is really sort of the most simple database imaginable. And every other database can be a key value system. So I don't really see key value remaining as a type of database that people want to use. I think what is much more likely is that in cases where key value functionality is all you need, you will use one of the existing technologies that you've already built investments and skills and best practices and integrations and test plans and deployment methodologies around as a key value store, because you can do that with every database out there. So I think what you're left with is basically relational, document, and graph. Because the wide column products are key value stores. There's really not much there that you don't, it's sort of like the worst of both worlds. It's key value functionality, but you also have to do some data modeling up front, and you lose some of the flexibility that you have with a document store. So the wide column products are I would put in the category of key value, and I would again say, so where you end up eventually is document and relational and graph, where graph really is useful for a very specific niche set of applications. So it's useful in some cases, but mostly your applications are going to be document or relational in nature.
Okay, thank you. It was very interesting. Another question is about integration between databases and MapReduce. MongoDB, as well as some other databases, are strongly integrated with MapReduce paradigm. Is there a need to integrate these databases with other programming paradigms, like bulk synchronous parallel, for example, or should it be just for graph databases?
Well, I think we'll have to see. I mean, right now, the market is, so just to give you some history on MongoDB, we started, our first foray into how do you do sort of batch routines that touch most of the data, right? So because in an operational database, and it's sort of an online customer-facing database, most of the application is interacting with a very small set of data from the entire total database, right? One user is interacting with data about themselves, or it's this order that you made at a store, or you made these phone calls this month. And that sort of workload or application is very different from an offline or an analytical workload where you want to average the values or add them all up or get the maximum or the minimum across all of the data or a large set of the data. So with MongoDB, the first step in that direction of analytical offline capabilities was by building MapReduce into the product. And that lets you do some things that you couldn't otherwise do. But it also made you use the system in a way that was challenging and new, right? And so this is something that you see very commonly with Hadoop, for example, is it looks like you can do lots of great things, but we can't find anybody who knows how to do it. MapReduce is this elite skill that almost nobody has. So what we as MongoDB evolved and matured, we added the capability to do the same sorts of work, but much more easily using something called the aggregation framework. And this is where you can write a small document that basically says, I want to do aggregates of types 1, 2, and 3 across data that satisfies these criteria. Very similar to the types of things you do in a SQL group by statement. And what we found is that that capability, while not as flexible as MapReduce, gave most users what they needed most of the time, and it operated 10 times as fast as the MapReduce capabilities. On Hadoop, you see a similar pattern where MapReduce was the first step, and now people are adding other sorts of capabilities because MapReduce isn't terribly easy to use. So we have adjusted the product based on the market needs and what the market has expressed interest in, and we'll have to see what other sorts of programming models or processing models people want to apply in the long term.
Okay, thank you. I would like to go back to standardization, but from the different angle. Standardization is one of the big advantages of old SQL world. So do you think there is a place for unified query language over all database types? Or should there be one separate language for each data model? Or maybe no standardization at all?
I think that the idea that SQL is a standard is an absolute myth. Yes, a committee of people got together and defined a standard for SQL, but anyone who's ever tried to migrate an application from Oracle to DB2 or DB2 to Sybase or any variation understands that every single relational implementation has proprietary extensions to the language that require you to rework the SQL so that it works on that particular platform and not the other platforms. So conceptually, the SQL is the same, right? And if you know SQL in one system, you can learn the tricks and the ins and outs of the other systems pretty easily. But this idea that there's really just one query language that works in all cases on all relational databases, it just isn't reality in my experience. So what we've and I also don't think that there's one language for all database systems, right? That you could potentially build something like that, but it would probably be like a key value API, right? Because the capabilities of all these systems are very different. And if you want one universal language, you're probably going to have to sacrifice the unique capabilities of each underlying product. So I think when you look for standards, there are two kinds in my experience. There's the kind that is defined by a committee. They take a long time. Sometimes committee members don't have the standard's best interest at heart. And the basic process is democratic, but it might be something that isn't actually terribly useful because it's an amalgamation of all these different opinions. The other sort of standard is what is most popular, right? It is the standard because it's what people use the most. And I'll let Matt tell the story about IBM and how IBM thought about JSON as a data encoding structure and developing a standard around querying the JSON and working with JSON across their product lines. Matt, do you want to tell that story?
Well, I think you already told the essentials of it. I would just add, as in terms of context and color, IBM recognized that they needed to do something about modern application development. So DB2 is a fantastic database, but not widely used by modern developers for, say, mobile applications or web applications. So they looked around and said, well, what could we integrate with and embrace that would, and help to standardize that would we could marry well with DB2, so we could drop data into DB2 from the system, but that would have an approachable interface for developers. And they looked around and they looked at a range of different NoSQL and NewSQL technologies, and focused in on different NoSQL technologies, and then they ultimately chose MongoDB because, as they said, and they'll tell you, the community around MongoDB was just dramatically bigger and more vibrant than anything else, and the technology happened to be pretty fantastic too. So they came to us and said, guess what? We've actually already built integration with your wire protocol, and we'd like to embrace it as a standard, and we'd like to work with you on it and build a broader community around it. And we said, that's fantastic. Let's do it. And so we are actually at the early stages of that. The integration has been done by IBM, but we're now in the process of going out and recruiting other companies and individuals to work with us in further developing the standard. And so there'll be more news on that. But I thought it was significant that one of the biggest database companies in the world, one of the biggest relational database companies in the world, elected to go with a NoSQL database so as to reach out to modern application developers, because they recognize that that is where development is going and frankly has already gone.
Okay, thanks. I'm actually out of questions, so if you have something to add to the European community, something that you want to say, that's about time.
I myself don't think I have anything to add. We do really appreciate the opportunity to talk and to help provide some perspective on big data and NoSQL, and would welcome the opportunity to continue the conversation with anyone else. So thanks for inviting us.
Okay, thank you, Matt. Thank you, Kelly. It was a very interesting interview. Thank you.